So here is another question on the general nth term of an arithmetic progression from the end. So it is given, find the sixth term from the end of the AP given by 17, 14, 11 up to minus 40, which is the last term. And again we have to find the total number of terms that are present in the given arithmetic progression. So here first we'll write the arithmetic progression. Okay, so here we'll write the arithmetic progression. So it is 17, 14, 11 up to the last term, which is minus 40. So here we have the first term equal to 17. Okay, the common difference, that is equal to 14 minus 17, 11 minus 14, it is equal to minus 3, the common difference. And the last term, that is equal to minus 40. So here it has been asked to find the sixth term from the end, from the last. So here we will use the formula for the general nth term from the end, which is equal to L minus n minus 1 d, the nth term from the last. Okay, so here L6, which is the sixth term from the last, that will be equal to L minus 6 minus 1 d, which is equal to L minus 5 d. Okay, L minus 5 d. So here we'll just put the values equal to L, which is equal to minus 40 minus 5 into minus 3. That is equal to how much? Minus 40 plus 15. Minus 5 into minus 3, that is plus 15. That is equal to minus 25. This is the sixth term from the end. Okay, the sixth term from the end, from the last. Also, we have been asked to find the total number of terms. So here we'll do this in a different way. In the previous question we used the general nth term formula from the first, that is Tn is equal to a plus n minus 1d. Here we'll use the general nth term formula from the last, that is L minus n minus 1d. So how we can use this formula to determine the total number of terms? Okay, so if we count the total number of terms from the end, okay, if we count the total number of terms, this is the last term, okay, this is the last term, and this from the end, this is the last term, and if we proceed from right to left, this will be the first term of the AP, it will be the last term from the end. You are getting my point? If we proceed from the last, from the end, this term, which is actually the first term of the AP, if we count it from the first, from left to right, this first term, it becomes the last term from the end. Okay, so here we want to find the n, the value of n. So here we'll substitute Ln is equal to 17. Okay, Ln is equal to 17, which is the nth term from the last, the nth term from the last. And if we determine this value of n, we will determine the total number of terms. Here when we use the equation a plus n minus 1d, for Tn we use this term, the last term, okay, that we used to determine the value of n. When we'll be using this equation, we'll be using the first term, okay. A is equal to ln, that is equal to L minus n minus 1 d. Okay, we'll use this to find out the total number of terms using this equation. So let us do that. So here L minus n minus 1 d is equal to A, which is equal to 17. So here the last term is how much? Minus 40. L minus n minus 1 into d, the common difference, which is equal to minus 3, that is equal to 17. Okay, so that implies if we take this minus 40 to the right hand side, it gets added here. So that implies minus n minus 1 into minus 3 is equal to 17 plus 40. Here minus minus becomes plus, so that implies 3 into n minus 1, that is equal to 57. That implies n minus 1 is equal to 57 by 3. 57 by 3, which means it is equal to how much? 19. Okay, 57 by 3 is equal to 19. That implies n is equal to 19 plus 1, which is equal to 20. N is equal to 20. That is the total number of terms is equal to 20. So if we want to verify whether this approach works the other way, that is a plus n minus 1 d, that is equal to the last term here. If we use this a plus n minus 1 d, then it will be equal to the last term, which is equal to minus 40. Okay, that is equal to minus 40. So if we use this approach, let's say whether we are getting the same value of n or not. So that implies here a plus n minus 1 d is equal to L. Okay, that. So here a is equal to 17 plus n minus 1 into d, that is equal to minus 3, is equal to the last term, which is equal to minus 40. The last term is minus 40. So it's lagging a bit. Okay, minus 40. So that implies minus 3 into n minus 1 is equal to, the 17 goes to the other side, so become minus 40 minus 17. That implies minus 3 into n minus 1 is equal to minus 57. Minus minus gets cancelled, becomes plus. That implies n minus 1 is equal to 57 by 3. Again the same way, this becomes 19. That implies n is equal to 19 plus 1, which is equal to 20. So n is equal to 20. So either you go this way, that is a plus n minus 1d, or L minus n minus 1d. A plus n minus 1d with the last term, L minus n minus 1d with the first term, you will get the same result. Okay, you will get the same result. This. Either way, you will get the same result. Okay. So here is another question on general nth term of an AP from the end. So it is given to find the 11th term from the end of the AP given by 10, 7, 4, up to the last term, which is minus 62. So here first we'll write the arithmetic progression, the terms. They are 10, 7, 4 up to the last term, which is minus 62. So here the first term is 10, the last term is minus 62, and the common difference is 7 minus 10 minus 3, 4 minus 7 minus 3. Yes, the common difference is minus 3. And simple and straightforward, we have to find the 11th term from the last. Okay, the 11th term from the last, from the end. So we'll use the formula for the general nth term from the end, which is equal to L minus n minus 1 d. This is the formula for the last term from the the general term of an AP from the end. So the last term L is equal to minus 62. So here L11 is equal to L minus 11 minus 1 d, which is equal to L minus 10 d. Okay, L minus 10 d. So it will be equal to L11 is equal to minus 62 minus 10 into minus 3, which is equal to minus 62 plus 30, because minus 10 into minus 3 is minus minus plus, so minus 62 plus 30, that is equal to minus 32. So the 11th term from the end for this AP, that is equal to minus 32. Okay, so this is the thing.